Okay, so we're going to repeat the steps from the previous problem. And so the question was asked, what's the pattern? That goes back to the top of this page. What's the pattern being shown in 4B? So hopefully it's side, side, side. You are given the three sides. You were told this length here is 15, for example, and this length here is 7.5. And then the bigger length, or longer length, this side GE is 157.5, and this length here is 130.5. And what we're trying to figure out is, can we come up with a proportion that will actually work? So, placing G on top of G prime, you're trying to find those lengths. First of all, we're asking the question of the segments parallel. That would be FC and DE. So as long as the angle at C and the little angle here at D that I've marked are congruent to each other, the answer would be yes. And so when you create nested triangles, you are placing the triangles in one side of the other, where they're sharing one angle, and the corresponding angles are, or the congruent angles of the similar triangles are also corresponding to each other. So the angle C and D, and the angle at, here I'm marking F and then E, those angles are going to be congruent to each other. So that's the way we set up nested triangles. So we are forcing the triangles to have parallel sides. So the answer would be yes, these two segments would be parallel to each other because the corresponding angles are equal. Ask you to write a proportion that works. So if I go back to what I did previously, I took the 157.5 and I took away the 35 to see what's left. And what is left is 122.5. So I'm taking these two pieces here. That's going to be one of the ratios. And then for the other one, the 130.5, I'm taking that length and subtracting away 29. And I'm finding that length to be 101.5. And so I'm setting up a proportion using those two pieces. So in the previous problem, what I did was I basically took the two sides of the triangle that are being split by the smaller triangle, and I paired those two pieces together to make the ratio. And so in the previous one, that worked. So here the question is, if I do that again, and I cross multiply, does 122.5 times 29, will that give me the same answer as 35 times 101.5? And if the answer is yes, that would be the second time that I've split the ratios by the split sides. So 122.5 times 29 is 3,552.5. And 35 times 101.5 is also 3,552.5. So it works again. So we can create a proportion using the two sides that are being split into pieces by the nested triangle. Ask you to do the same thing for the third one. And so before we jump into this one here, going back down to this problem here, the question is, what pattern is this one showing? And the answer is angle-angle. It does have some sides, but we don't have a side-angle-side pattern, for example, in the bigger triangle. All we have are two angles. We don't have three sides. We don't have two sides with the angle between it. So angle-angle is what works here. But there's the issue with this one in comparison to the previous problems. In the previous problems, I was able to split the 54 into two pieces. That would be the 18 and the 39, and I was able to figure out what was left of the 54 and 117 because I had two numbers which I was splitting the longer sides into pieces. Same thing was true here. When I put this side in here, I know this angle, this length is 35, so I can find out that piece, what's left of the 157. And here, same thing, it's 29, so I can figure out what's left of the 130.5. But here, for example, if I place the two congruent angles, G and D, on top of each other, because we'll look at the congruent angles to create that nested, or if I put the F on top of the F prime, for example, the problem is I don't know how long that side is, which is FE. So I can put in this triangle here, for example, and I know this side's 35, and I can find what's left of the A7.5. But on the other side, the 24, I don't know what's left. So before we are able to do this problem, we need to figure out the length of F prime E. So based on the work we've done so far, go ahead and please find the length of line segment F prime E first. And that way we have the lengths of the side that is, the two sides are going to be split by the smaller triangle. When you have the length of F prime E, please turn the video back on. So to do that, I'm going to use the same techniques that I've been using up to now, which is I'm going to circle one of the triangles and put those numbers in the denominator. The 35 corresponds to A7.5, and the 24, that side corresponds to the side that we're missing, which is the F prime E. Cross multiply, so 24 times A7.5 equals 35 times F prime E. And I'm trying to figure out again what that total length is. And that's going to be helpful because again, I need to know how to split the FE. One length is 24, what's the other piece? So A7.5 times 24 is 2100. And if I divide by 35, F prime E is going to be a total of 60. Now I'm able to figure out what that little piece is going to be. That would be CE. So that's critical for this problem. You have to know at least two of the three numbers. So each side is broken into two pieces, and you have the total length. So of the three numbers, you have to have two of them to be able to find the third one. So going back up here, so this length here is 60. And that length is A7.5. So if you would go ahead and find the GD piece and the CE length, again, the lengths parallel, as in GC and DE, set the proportion. You may have a different way of setting it up. We're trying to find some consistency that will work here. And then when you're finished, move on to problem 19 and develop a general rule. So based on the setup you're doing, how would you set the proportion using the letters, and then cross multiply to get that final answer. When you're finished, turn the video back on. All right, so the A7.5, take away the 35, what I'm left with is 52.5. So those are the two sides I'm going to make the one portion out of. And then the other side, we take 60, take away the 24, and when we left with is 36, and that is going to be my second piece. Again, I put the larger over the smaller, so I'm going to put the 36 over 24. It's really important that you watch the placement of the numbers, because if you have a ratio where the bigger number's on top of the first one and the smaller number's on top of the second one, there's no way that the cross multiplication will ever work, because one ratio is more than one and the other ratio is less than one. So watch the numbers. So again, checking this out. So 24 times 52.5. Do I get the same answer as 35 times 36? So 24 times 52.5 is 1,260. And 35 times 36 is also 1,260. So this is the third time that I have taken the two lengths that are being split by the smaller triangle, and I have created ratios using the two pieces from each side, and the ratio seems to work. The question going back to, are the lines parallel, and that would be GC and DE, and the answer is yes, because the corresponding angles of the G and the D, the ones that are marked, are congruent. So in all three of these problems, the answer is, are the line segments parallel? And the answer is yes, because the corresponding angles are equal. And we're kind of forcing that, or making that happen in all three cases by making sure we place the triangle correctly inside of the other triangle. So we're making sure that the corresponding angles are the same. Therefore, the segments are parallel. All right, so on this rule, I've kind of used the word multiple times. This is actually called the side splitting rule, because basically what I've done is I've stuck one triangle inside the other, and I split two sides. So I've approached it by using the two pieces off of the one side that's split and create the ratio with the other sides, those two pieces that have been split. So the W goes to Y as G goes to P. So I'm basically going top to bottom in this case. When I cross multiply, I get W times P is equal to Y times G. So you may have a different proportion set up, but as long as our cross multiplication answer is the same, WP is equal to YG, your proportion will also work. So this is called the side splitting rule. So what we're being asked to do, starting in problem 20, is use the side splitting rule to find the missing piece. So if you go ahead and try to find X in both A and B. When you're finished, turn the video back on. All right, so on the one side, I'm going to pair up the 20 and the X. On the other side, I'm going to pair up the 33 and the 78. So I'm going the same direction, so 20 over X, 33 over the 78. Cross multiply. You get 20 times 78 equals 33x. Then if I take 20 times the 78, get 1,560. And then if I divide by 33, you get an approximation here of about 47.27, actually 27 is repeating. 47.27 repeating. In the second problem, same thing. The side splitting pieces on the for FD and the side splitting pieces for FE. So we do 25 to X as I go from top to bottom, and 34 to 88.4. So if I cross multiply, 34 times X is equal to 25 times 88.4. 25 times 88.4 is 2,210. And then if I divide by 34, get an exact answer of 65. A few more problems left. If you would go ahead and complete those on your own. And then you will move on to the homework assignment, which is Chapter 7, review number 2. So for the final problems C, D, and E, problem C, you have to actually find this piece here by subtracting these two numbers. They said the proportion using the side splitting idea, get 26 here, 26.57 here,